So our next panel is dealing with, well, as you see, microgrids, battery storage, and solar. You're going to put this things over there. So Jim Spano is the managing partner, Spano Partners Holding, LLC, and co-founder of Solar REIT. As developer and prominent advocate of solar energy, Jim is the founder and president of the New Jersey Solar Grid Supply Association, a director of the Mid-Atlantic Solar Energy Industry Association, and a board member of the International Battery and Energy Storage Alliance, and sits on a number of corporate and nonprofit boards of directors. And he's a very active member that I call, send emails to all the time. So appreciate you being here and putting together this panel. Thanks, Jerry.
Thank you, and welcome to the Energy Conference. And hopefully you'll find our presentation and our panel quite interesting. We're going to be speaking today about smart grids. We'll be speaking today about smart grids and solar storage, and how we build and manage these systems. And interestingly enough, unlike many of the presentations on new technologies and so forth, this is a technology that is new, but it's not theoretical. This is a technology that's being implemented. There's a microgrid being built in Jackson, New Jersey, which we'll have a little case study on in a few moments that the panel will be discussing. Let me start by introducing our panelists. Our first panelist is Adam Zellner. Adam is the president of Greener by Design, a global energy, resiliency, and sustainability consulting firm. Adam works directly with a variety of corporate and government entities, including several Fortune 500 companies. In addition, he works on policy issues both in the United States and overseas, hosts and attends a variety of policy think ads, and is a solid partner of Spano Partners, and we appreciate all the work that Adam does for us. Then we have Len Pisano. Len is Director of Operations at Green Power Crossings, which is the company that's building the microgrid in Jackson, New Jersey. Len specializes in designing, building, and managing advanced sustainable technologies that solve complex problems and improve our quality of life, and has excelled in several C-level positions for over 2 decades. He founded Maximum Performance Group, which provided turnkey energy management solutions. And during the last 5 years, Len has been providing consulting services in energy tech, smart energy management, and renewable project development space for various users in the commercial, industrial, and higher education markets, as well as supporting various companies that are integrating smart building technologies into their delivery model. Our next panelist is Brian Tannenhouse. Brian is the owner of BD Engineering. He's a capable and diligent electrical engineer who's tackled large and small projects with a high level of attention to detail and dedication to the profession. For the last 18 years, Brian has been involved in the planning, design, management, construction, support of facility engineering within the architectural and engineering industry. Brian specializes in electrical design and service calculations, demand load analysis, infrastructure evaluation, code analysis, equipment layout coordination, and project management, and is one of the owners and founders of BD Engineering, licensed to provide engineering services in 5 states. And then lastly, we have Adam Weinstein. Adam is the executive sales manager at Sonnen, where he oversees sales across multiple channels and geographies. His passion for sustainable building practice and emerging technology fuels his success in the workplace, where he helps solve complex energy problems and moves a growing base of people towards energy independence. With that, we have a quick slide on the various companies that are represented by the panelists today and their companies. There's a number of private schools and private institutions, a number of municipal utilities and nonprofits, as well as commercial and industrial private clients. A few of them are just listed there. With that, I will begin the panel with Adam, his presentation on microgrids. Adam.
Thanks. Hi, everybody. It's good to see the crowd. So a couple things, as Jim said, we're going to talk more about reality of what's going on. And for BIA and the conversation to be had today, and I see some of our new board members, we're in a serious situation, right? The conversation about plasma and all that's going to go on gives great hope and everything else. We are in an interesting place over the next 25 years. I just came back from Ireland. If anybody's looked at the front page of any Irish newspaper, you know they're in trouble. Their grid is collapsing. Air grid is going to fail very soon. I'm back from Texas. ERCOT is in trouble. Its grid is going to fail relatively soon. Utah is in trouble. California is in trouble. And this is not trouble tomorrow, not 2030, not 2040, not 20, whatever it's today. And you see this perfect storm. I love this slide because it does tell you everything that's out here of what's going on. It's not about resiliency anymore. And I don't know where the clicker is. We can just click to the next slide. There you go. Thank you. It was about resiliency, but now it's about you guys. So I'm working across the United States and in Europe. We represent every kind of big company you can imagine, from a quarry who owns ports on both coasts on down through waste management and others. There are people getting notices all over the United States of America today. Congratulations, lawyers in the room, that said that firm power that we had, we don't have it anymore. It is happening every place. We have a map of the Great Chasm, the Great Divide, and New Jersey is actually up here at number 6. At the top, our friends from Texas. And then right underneath it, Virginia, collapsing. And on down, what is the chasm? There are 8,760 hours in a year, 8760. And right now, there are states that have 1,800 hours where they cannot produce enough baseload power, right? And this means jobs are being turned down, economics are going away, investments are going away. We are losing hundreds of millions of dollars. Ireland is thinking about kicking out industries right now. They spent 20 years revising tax rates to bring in business, and guess what's happening? And this is happening all over here. It's why we're here today. It's why Vito and his investments in Adventure Crossing, right? There's not enough power. In addition to the fact that we just talked about plasma and all the wonderful things, guys, you got to be able to get the energy there. And I know people think it's going to happen remotely and virtually and over the waves. It's not. It's going to be delivered on a wire for a long, 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 long time. And so there's this interesting dichotomy of where the power comes from and how much. And then the other side of this is, can you deliver it, right? To be honest, if the plasma was up all over the state, it wouldn't help my clients. I can't get the power to the projects. There's not enough room. The substations aren't big enough. And the rubric of what we do today and spending money on having developers reimburse for their investments is totally counterproductive to what we're talking about. We're talking about building solar and other things that are behind the meter to try and get buildings to be self-sufficient, right? And at the same time, we're telling developers to put out money to build substations because they'll get reimbursed when the electricity moves back and forth. What are you talking about? It's not going to move back and forth, right? And so this perfect storm has created something else. This shortfall in energy is expensive as hell. For anybody who's sitting here, COVID has done one thing, and it's done many things. But one thing I know very well, my data center clients are through the roof. We have offices all over the country now, Europe, as I said. Data centers are looking for space anywhere. If you've got 50 megawatts of relatively cheap power, just let me know when I get off the stage. And so you can't find it, right? And it's been accelerated because everybody's at home. Everyone thinks the energy dynamic has changed. It has. You've become a bigger pain in the butt, right? You're here, you're there, you're home, you're at work, you're everywhere. And by the way, you turn it all on. We have no more capacity. I can't move any more data. There's no more data center space, right? I can't build one in Virginia. They have a moratorium. They have a moratorium in Texas. They have a moratorium everywhere. Why? Some can't deliver the power and some can't get the power. And one thing, to give the utilities credit, we all lied. We're all liars. Why do I say that? Because in the 80s and 90s, and I worked at lots of you, we all told the utility we needed lots of power, right? Because we were building phased developments. We were going to grow our campuses, our pharmacies were going to grow, right? And there was no charge to holding this power and reserving it. And over the years, the utilities got used to the fact that you didn't really need 50 megawatts. You needed 12, and it might have grown to 20. So there was always extra capacity. Hold on. Then you plug it in, you electrify it. At Mar terminals alone and along the port, we'll take out diesel. DEP folks here, good job. We got the diesel out. We electrified it all. Want to know? It's about 1 nuclear plant's worth of electricity for our cranes, just alone. We have 240 straddle carriers, 240, quarter megawatt a pop. That's just one terminal. You're going to electrify them all in 12 years, right? And so that place is at the ass end of the grid, literally looking at New York on a single human hair that carries it, right? And so there's a perfect storm that's happened. It's not happening here. This chasm I can show you, it's all across the country. There's a lack of investment. there is a hope that the wind and it's all coming, right? It's going to be here, as Jim said. This is here now, guys. We are in the current situation. It's going to continue to exacerbate renewable portfolio standards. I had the pleasure of writing one in a day. They're awesome. But when you begin to map out the RPS, you begin to map out the wind, you begin to map all that stuff, what fills in the baseload? It's not 8760, it's 1,000 hours. But if you think it's okay not to operate your business 1,000 hours a year, raise your hand and let me know, because you're perfect for Texas, right? Where they can shut it off. And everybody thinks it's like not happening. It's just California, because California is nuts. California is nuts. But it is happening in Virginia and Texas. I'll leave that hang in the political season. So we can go ahead, next slide, right? So part of this is how do you do this? And to the senator's great speech, right? Part of this is ebb and flow. And you know, the craziest world that you could live in is you build power from here and you bring it from far away through transformer and you step it down and you carry it along wires that are like hanging out right now over the highway by 22%, right? Everybody's leaning on it. And you don't ever think, well, you know, as we're growing and we're growing, we're getting more power in the distribution system, more data centers, more indoor agriculture, more STEM, more research, more everything you want. We need to start reversing this. A one-way highway that delivers power from hundreds of miles away doesn't count. We need to start thinking about how we localize energy supply, how we harden the supply with large users, how we bring infrastructure to the cities. And one more thing, for all of us, and all of us know this, and I've known all of you guys a long time in some cases, right? We have this other mighty entity in the state. Everybody knows what it's called. It's called the mayor. The mayor is the mightiest entity. He, she controls the local planning, right? A master plan. Ratables in the state of New Jersey are not what people think. It's not just taxes, it's schools, it's parks, it's recreation. It's actually why people move and live here, right? Because we can educate people. We complain about high property taxes, but sometimes we don't actually do anything about it. One thing that's very stunning is when mayors start to lose major ratables, when they begin to start to think about electricity becoming a hindrance to their redevelopment, when they begin to start thinking about how it interferes with their ability to bring those taxes on, for any of you who've not been in the way of a mayor and a ratable, you should be careful. And so they're beginning to think about, how do I relook at power supply? How do I begin to develop these microgrids, these distributed generation plants? How do I use solar and storage? And yes, gensets, and yes, they will use some gas in the beginning. I'm sorry, get the hydrogen there. We're waiting, we'll wait for the plasma, we'll wait for it all. At some point, if we don't wake up and look in the mirror, you are not going to get hospital expansions. Everybody see Cooper's $2 billion expansion? Needs power and a lot of it to do it, right? And when you begin to look at delivery and electrification of FedEx, UPS, and every other thing, transit on its mission, which is great. I'm getting rid of diesel because DEP told me to do it all over the state. This is all awesome. Guys, our plug load is growing exponentially every minute, every hour. You're not going to make it till 2040. You are not. And so you need to find a localized solution, and that's what we're working on. That's what these ideas of microgrids are. That's this whole concept of bringing power to the distribution system and being able to set up the infrastructure so when power comes, when more renewables, when it all gets here, we're ready, right? There's no harm in setting up infrastructure and going away from a one-way highway. So that's the layout. I'll close my part on this, which is one of the great things about having local mayors and having master plans and control. You can begin to stop reacting, right? Leg comes up. Every time the utility has to react, you show up, I need this many megawatts. Wonderful thing about towns is they have master plans. You can see it coming. You can begin to work cooperatively. You can begin to work with a developer to kind of mold it, make it possible so that the energy that you'll hear about, the systems, respond to the development in a way that's friendly, right? Instead of us just constantly reacting to what's going on, because no one in the utility world sees the master plan that has the redevelopment area that could have told you that was coming 5 years ago. So let me stop right there. And I know we have other speakers. Thank you.
Okay, our next speaker and our next panelist is going to be Adam Weinstein. Adam, you can sit. We give Adam Adam Zollner the stage because he's a little bit more animated and isn't able to sit still for long enough. But Adam Weinstein from Sonnen is going to speak to us today about virtual power plants and integrating a virtual power plant with a microgrid. As we all know, a microgrid is an independent power station that operates independent of the grid or in conjunction with the grid. And a virtual power plant is an aggregation of smaller systems into a larger power plant through a software algorithms that enable small systems to operate and respond to the grid signals similarly to a centralized storage system. So Adam, all yours.
Jim, thanks so much. And yeah, go ahead to the next slide there. So what's exciting that Sonen's able to do, and this isn't a future concept. Sonen as a company has been around for a little over 12 years now, founded in Germany. We have about 100,000 batteries that are participating in swarm control grid services in Germany and across other countries in the world. So Italy is an emerging market of ours as well as Australia and here in the US. But as Adam just mentioned, these grid challenges are now. They're in places like Utah, like Texas, like areas here, like California, of course. And the question is, what is the solution and how do we harness the renewable energy that's generated in order to dispatch and harmonize the grid? And we believe we do that with decentralized energy storage, being able to swarm control batteries to do so. Here you can see the hallmark of our work, the Sonen VPP. The Sonen community in Germany was established in 2016. The batteries themselves has been relatively into the markets since 2018. Tens of thousands of dispatch batteries are currently operating. You can see every little blue dot in that globe picture on the bottom right is an actual battery. It's quite more than that at this point. And that is a solution that we've been able to develop for that market. Next slide. So this started with a really exciting project in Utah as far as our Rocky Mountain Power integration. The developer decided that they had a huge problem in Utah with air quality. They wanted to create a development that contributed to the health of the community. They knew that just solar was not going to be enough to achieve this. What they decided was they were going to have solar and storage included for their development of 650 apartment homes. Every home has a Sonen battery located inside of the living space. And those batteries are being used every single day by Rocky Mountain Power to provide clean energy and stabilize the grid in that market. What's been really exciting about this project specifically is the impact it's had on the stability of the grid and providing the clean stored energy in addition to resiliency to the customers. So the homeowners themselves experience independence and don't have grid outages, of course, but the utility is finding that economically it's beneficial for them to operate these batteries, dispatch the stored energy during peak times of the day, and harmonize the grid utilizing this decentralized energy storage solution. This program's been so successful with the initial project that they developed incentives for homeowners to adopt energy storage. Rocky Mountain Power achieved so much benefit from this type of arrangement that they're incentivizing homeowners with thousands of dollars up front to install a battery with solar and then continuing revenue generated from that for the homeowner beyond that initial payment. And then the Sonen model directly complements core solutions to the problem. As I mentioned, obviously California, Texas, and other areas of the grid have their own challenges. Sonen's able to adapt to different models and provide grid services for vertically integrated utilities as well as semi-deregulated and regulated markets. Here's an example here of a few different models. Number 3 being deregulated markets such as ERCOT. We have thousands of units that will be deployed into Texas coming up in the very near future to assist with their grid challenges. Number 2, you can see is California CAISO market. Same situation there. We're right now deploying thousands of batteries into that market to assist with their grid services. And then, of course, number 2 being the market here in the Northeast. We're well equipped to handle the grid challenges that we have here in the state. Sonen Connect California was announced very recently at the RE Plus Expo with Baker Electric. This is another incentivized program for homeowners to adopt batteries and for those batteries to contribute to grid services in California. And this is just a little bit more about our project in Texas, which is coming up, where again, thousands of batteries will be deployed to assist with the grid challenges and provide resiliency in the Texas market.
Okay, thank you, Adam. A couple of comments on there real quick. First, on the Utah project, it should be known that a New Jersey company supplied all of the battery systems for that project, a company called Microgrids. And on relative to the slide where you had a number of different states that they're developing these PPPs in, Should be noted that there are VPPs being developed in the state of New Jersey as well, and we'll talk about them at another date. Our next speaker is Adam Zellner again. This time we're going to have Adam speaking as to where we are today, what we need to do to get to where we need to be. And then subsequent to that, we'll start a short conversation. We're going to run out a little time, so we're going to have to push this ahead, guys. A small presentation on the actual Adventure Crossings project, which is the first ground up microgrid in New Jersey. Be providing over 25 megawatts worth of power to several hotels, convention centers. We'll talk about that a little bit, and there'll be a slide showing, or a presentation showing the Adventure Crossing project as well. Adam?
Yeah, I mean, I can be real quick with this slide because you guys have heard this all day. The reality of creative New Jersey people is we get projects built, right? And between redevelopment law and between the sort of twister that you see up there and kind of stretching some utility easements and making sure we don't locate over this lot and this block and this everything that makes the franchise rule, we have been able to develop these community microgrids with a lot of help from the BPU. And I saw Rick Rose in here before. There he is. And thank you to all your help, Rick, in the past year. And so it's a challenge, right? Because we're spending time, effort, lawyers, engineers, architects, utility time. By the way, very clear, PSE&G and the other utilities have been great. They're working with us hand in hand on these microgrids now, but they're also bound by rules and regulations, right? And so the one thing that comes out of this is trying to make life easier, incorporating municipal master planning, incorporating power. Utility master plans have looked at transportation, they look at water, they look at wastewater, they look at economic development. Underneath all that, really, none of it works without power, not a single thing, right? And so we're trying now to work with both the utility, the board, others to make this a normalized process where we can begin to engage, to develop distributed generation, to develop projects like they are through redevelopment law, and to allow the rules and regulations to help bend to make it happen, because the redevelopment process, for anyone who's been through it, is a robust, public, sometimes like dangerous process. If you catch it at the wrong time at a public meeting, you can have some things thrown at you, definitely. And so we believe this is a really robust way to work with the utility, engage them, engage the towns, get to the ground to help create it. And by providing some rules and regulations, some tariff rates that the utility can understand, we begin to partner with them, because I'll tell you, to speak on their behalf, since they're not allowed to, they're interested in hardening and burying their stuff too. They just have to do it in a very prescribed way. So our hope is, coming out of this, that we can find a future where, instead of playing twister, because I'm getting a little old for the back, we can do this in a more linear way that is easily understood. Once you do that, the market does have a funny way of coming in behind it. Once you all see how to make money on it, it does become a little easier to build. So with that, Jim, I know we're short on time.
So a couple of things that we have, we're going to be speaking about the Adventure Crossing project in a moment, but a couple of things that we want to just make note of that can make things far more efficient to build these microgrids in the state. We have, as Adam mentioned, geography boundaries. We have limitations as to how we can cross property lines. Well, when you're building large complexes and campuses with multiple lots and blocks, having rules that were intended and designed for one purpose being applied towards a microgrid situation, it just doesn't work. We need to be able to cross boundary lines. We need to be able to move power from a centralized microgrid to all of the users within the various properties on that campus. We also need to enable residential systems to operate concurrently with the microgrids so that they can communicate and support each other. At Venture Crossings, we have a large microgrid. We were planning on building a virtual power plant, but we couldn't cross property lines again. So there's some issues that eventually we're all going to have to address to enable these microgrids and this distributed generation to really take place. Obviously, with distributed generation, we end the power security problems that we have today. If anybody is aware of what happened in Texas, you know that having distributed energy would have made a huge difference. Providing seamless integration of those VPPs without compromising utility requirements, coordinating renewable policy with microgrid development. All the rules that apply to solar in a traditional net metered use need to be relooked at when the solar is being used within a microgrid environment, and that's where the geography lines all have a significant impact. What we're going to do is we're going to give a sneak peek now about the Adventure Crossing case study. Len Pisano will be presenting it. In the background, we'll be playing a time-lapse video of the it's not a time-lapse video, it's a overview, a drone video of the current status of the property as of September. We had planned on doing a time-lapse, but we think that the current status is going to be much more influential, and so that'll be playing in the background.
I'm gonna stand so I can see. Play ball.
And so we've been crafting the design around building this microgrid around an already started construction project, which was not an easy thing to do. So ambitious plan developed nearly 300 acres, literally right next door to Six Flags Great Adventure. And the biggest challenge and the hurdle that had to be overcome was there was no infrastructure to support such a large development in this location. So there were two options: put in a really big substation and spend a lot of money, or get creative. And I'm happy to say that the team that was put together from the early stages of preliminary and conceptual design to where we are today, we were able to pull that off. See, the dome there is now fully blown up. So what had to happen was, you had to figure out what was going to be needed for the development in and of itself. And while all of this infrastructure was being built, what also had to be added in the anticipation of what was going to happen with the microgrid. Brian Tannenhouse is here, and he's going to talk a bit about how the electrical design and engineering team was able to pull that off. There are many elements of the microgrid were included in the electrical conduits and transformers, et cetera, that are going to be also used to dual purpose into the microgrid. So there's a lot of early collaboration between Adventure Crossing, Vito's development team and engineering team, and the Green Power Crossing team, which I'm very happy to be a part of through the feasibility stage. We'll go next. Yeah, so the team is really, it's pretty dynamic. You see on the left side, obviously, Adventure Crossing is the main developer, but the constituents of tenants that are coming into this site are pretty amazing. You've got the Marriott's, the Hiltons, a lot of retail, Topgolf. Vito's plans to build the MS Research Center on this site. It's no small undertaking, and it's a passion project of his, and we're just happy to be a part of seeing that to fruition. We'll go back one second. On the right side, Green Power Crossing and how we're interacting with BD Engineering and Brian's team, and then the entire team that is actually enabling us to get this microgrid built. Jersey Central Power and Light, GCP&L, has been integral in this process and has been extremely helpful all the way through. We've got above grid that's already almost 5 megawatts of solar on the site, ready to roll, ready to produce power. Sonen's getting specified on the battery side. Scale is a partner for the microgrid construction, and then Adams from Green Design, which has done a phenomenal job navigating all the elements that he talked about earlier. So, how do you get it built? It's an engineering process, but it's also a financial process. So we had to build a very complex financial model that was taking into account multiple tenant types. We actually had a point in time where this was going to be a cogen microgrid project with one of the tenants having a large thermal load, and we had a very flexible financial model to kind of basically do sensitivity analyses around all these different options. So tenant loads, commodity pricing, cost of construction, 40-year operational costs, all critical elements of developing an accurate and flexible decision-making tool. Because remember, this is a privately funded project. So the microgrid and what's getting built over the course of time has to be able to generate revenue. Otherwise, it all falls down. So we had many iterations of the model, and we analyzed a lot of specific data to get to the point where we are. And where we are now today is we're in full-blown design for an integrated solar battery storage and baseload generation project with no thermals. Again, you saw the diversity of tenants, so we have a lot of things to take into consideration, but we're very pleased with how this has all come together in our preliminary design. And so again, go back one second. Sorry. Privately funded, proving the case that the path to building clean, sustainable, resilient energy infrastructure to augment the base utility services while supporting positive community-based real estate development is clearly a part of New Jersey's future. I think everyone would agree. So I'm going to introduce Brian real quick. Brian, if you want to just dive into the electrical side of this. BD Engineering is a full-service HVAC electrical plumbing design firm. They have 16 years in business in New Jersey, and Brian's going to talk about some of the preliminary challenges that we had coming out of the ground today.
Thank you. Good afternoon, everyone. So some of our challenges here were design flexibility, trying to develop a electrical system that's going to be flexible enough and robust enough to allow different opportunities that the developer may come about while the project is being brought to fruition. We have different building types, as I said, that are in constant flux and electrical needs. We have construction phasing. We have to make sure that it's flexible enough that as construction continues, the system can be brought online at the appropriate time. And then for me, the thing that hit me home when I got involved in this project is the fact that all of this entire project is to fund and help develop Vito Cardinale's dream of having a multiple sclerosis research center, a state-of-the-art center that's going to save lives. This is not a project to put money in someone's pocket. This is a project that's going to save lives. And as Adam had indicated in his presentation earlier, I'd like to try to drive this home a little bit. We have a regional problem where we didn't have enough power for a state-of-the-art research center that's going to save lives. Adam indicated that a Cooper Hospital expansion is going to save lives. And I guarantee you, they probably have a power problem over there. So to utilize this microgrid really helps with not only the bottom line and ratables and taxes and all that stuff, but there's also a human component. In particular for this project, it's about saving someone's life. So with those challenges, go to the next slide, some of the innovation that we had to come up with was how do we develop a system? We're getting a little bit of power from the utility company. We need a lot of power from the microgrid. So the system had to be designed in such a way that the power we're getting from the utility company could come back to the final microgrid location in the back of the site. It then had to distribute out to each one of the various key points in the system to serve the various buildings, whether it be a retail center, a restaurant, the golf center that's going up, hotels, convention center, other types of projects, and or ultimately the research center. It then had to also be incorporated in a scheme that was controllable. So we had to develop the loop knowing that a microgrid was coming, because again, back to the phasing, we had to get something started in the site. So we're building the site out to what the utility company has given us capacity for, but then make sure that it's robust enough and has enough controls and smarts in order to be able to accept the microgrid. We did that through using underground distribution equipment with special Schweitzer 751 relays. For those that may be in the engineering world, that sounds interesting. For those not, it's just a better way of saying a very fancy computer that's going to control this thing. And the reason being is we want to sell the electrons. We need to get the electrons to the research center. That's our primary mission. But we also need to make sure that the tenants on that site also have reliable power. So if there is an issue with a piece of equipment, one of the cables in the loop happens to break, someone digs somewhere that they shouldn't have and clips it, we wanted to make sure that the loop, so we developed a loop that allows power and provides that redundancy that allows the electrons to flow from one side to the other and bypass that issue, or at least isolate that issue, and then repairs can be made and can continue on. Some of the other benefits of the system that we developed was the fact that power isn't always reliable. Well, now that we have a microgrid on site, we have and will have a certain amount of capacity available to us at all times. So what's interesting is when we have a regional power outage or a local power outage from the utility company, we're able to quickly come off of the grid, utilize our microgrid now to provide a much larger amount of power instead of having a small generator on a building and only powering up maybe a few lights and maybe some very key pieces of equipment. We can now bring in power from our microgrid and power up the entire building. So the dome house. Oh, it does. Oh, you zoomed dome. Yes. So we're able to provide our buildings for not only possible shelter in place type of scenarios and keep those buildings up and running fully, but for me, more importantly, it was about keeping that MS Research Center operational. The research that's going on, that research, way I approached the project was, it was as important, if not more important, than keeping a data center or your 911 calls continuing to move forward. So with this microgrid, we're able to come off the utility grid and through the control systems immediately get that research center up and running in any of the other buildings that may be needing power based upon the actual capacity that we have in the microgrid. So this microgrid offers a lot of benefits. And as Adam pointed out, it can handle both regional power issues, but it also provides that extra backup power that we'd all be yearning when we have, another Superstorm Sandy or some other ice storm of some sort.
Thank you, Brian. Thank you. So we're, as I said, as you saw, the site is well underway. Development has been ongoing. We're utilizing approximately 4 megawatts right now from JCP&L for the initial construction phases. As I said before, we have almost 5 megawatts of solar that was completed over the summer, and we have plans for 20 megawatts of micro capacity that's going to be developed and added to the site over the next 4 years in a modular fashion, which is going to enable us to be flexible, allow us to accommodate VDOS requirements as far as timing of tenants, type of tenants, etc. So we're in construction on microgrid with major equipment being ordered by the end of this year and in the ground by early 23. Long term, we will be having an operational partner. Again, this is a microgrid. This is a utility on site that requires 24/7, 365. So we will have on-site operators 24/7, and once it's operational, we'll be basically looking at this as a real-time, day-to-day plant that's got to be managed. A significant amount of power over the life of this site is going to be generated using clean renewable energy, and the site, as Brian said, will be 100% resilient. We do obviously have the opportunity to offer, as Brian said, shelter in place. The site's going to be live and lit up any kind of major storms or whatever's coming in. So it's a pretty dynamic project. It's been a very interesting year. Thrilled to be a part of it, and we hope you will appreciate what we're doing.
Okay, so I think what we saw today, we talked about why we're building the microgrid. When we started this, or Vito started this project, he didn't realize the lack of power to the site. As he began to develop and look for tenants and recognize that there was a significant lack of power, he found that he had to build a substation. And that's when he came to me and says, Jim, the project can't support a $30 million substation. How do we get around this? And that's when I built the team and said, okay, there is a way. It's not been done before. Not terribly risky, but from a financing perspective, risky. Financiers, as you all know, they don't like financing something new until it's been proven. But we put together a team of qualified professionals. We're able to convince financing that this team is capable of accomplishing what it had designed and had planned. So we immediately put together a plan for a microgrid, put out an RFP, got various respondents to propose their solutions. Ultimately, Len, who ran the RFP, chose the solution that we've elected to go with. Obviously, you heard that we were initially looking at a cogen plant where we would be distributing thermals, even put all the underground conduit in to support that thermals. Ultimately, as one of the risks of any large real estate project, tenants have to come and tenants go. As the economy has softened and as tenants are rethinking their plans, changes are occurring even as we speak. And we need that flexibility to address that. Remember, we had to build the entire underground distribution system, which is typically not part of a microgrid project, but because we didn't have the substation, we had to do this all on our own. What that means is that stakeholders were able to avoid the cost of all of that infrastructure. This is the kind of thing where private and public can work together, get efficiencies. We had so much cost that could have been avoided had we not been the first to try and build this microgrid. So we've learned a lot. We'd like the opportunity as we go forward to speak with the legislators and policymakers that are affecting how the distribution system in New Jersey is being operated. And we'd like the opportunity to have our team meet with them and describe the obstacles that we had, the workarounds, the additional costs that we had to incur to accomplish the workarounds. As I think Adam mentioned, we had a problem with moving solar power. As you saw on the video, we have solar canopies around all of the baseball fields, on all of the parking lots for all of the Taco Bells and 7-Elevens. We have, solar all throughout the site. Well, under the rules, we can't cross a line with a solar system. We can't cross more than one property line. So when we're building this, we need to sit down and look realistically at rules that were designed for a system that is now being transformed into a renewable grid. And we have to really think twice about how we apply rules that were intended for one purpose that are now being applied for a very different purpose. And we need to be looking at how we make exceptions, how we grant waivers for certain requirements that don't accomplish the purpose of the requirement when used in an application like a microgrid. I think the Adventure Crossing project is, I believe, the largest real estate project in New Jersey. And if we're going to attract and continue to build our economy in New Jersey, we need to address the power shortages. We have circuits that are closed all throughout the state. And we're going to continue to have that as we continue to develop renewable power, which we're now, we passed legislation to ensure that we have a clean future, clean energy future. But now we have to put in the policies and regulations that actually can facilitate it with these new technologies that are being developed. I know Andrew spoke about fusion. There's going to be, taking a fusion plant and putting it in the middle of an existing or a terminated coal plant or whatever. That infrastructure is there, but now we have to have the rules that enable the power to move in and out, as Adam had mentioned earlier. With that, I'm going to open up for questions, and then I'm going to leave just 1 or 2 minutes for Vito Cardinale to address the room and speak about his project and his goal for his multiple sclerosis center. So we'll open up for questions now. Any questions for anyone in the audience? Just identify who in the audience, on the panel, who you'd like to speak with. No questions? Well, then we thank you for your time and taking the time to listen and learn about microgrids and virtual power plants. And we'll look forward to any further conversations you'd like to have after the session. Thank you.
Got to bring Vito up.
Oh, Vito? You don't want to have it?
Oh, come on. Come on, Vito.
Just,
Come on up. Take the
I
time.
think it's important for people to understand the passion behind the Multiple Sclerosis Center.
He may not look sharp,
And
but he
this
is.
man has dedicated his life to curing multiple sclerosis. So, you know,
All right, well, I wasn't prepared, but I spent a lifetime watching what MS can do to somebody, especially to the woman who gave me my children and how much she suffered from it. So many of you may know about the MS Center at Center State. It's named after my wife. Take care of 3,000 people there that have MS every day. We're very proud of that. And unfortunately, building and expanding that center at the hospital isn't my goal anymore. I went to the Cleveland Clinic and I said to him, I'm an engineer, I'm not a doctor. I have an idea of how we can cure MS. I'm here with my toothbrush and a ticket to go home if you say no. Well, fortunately, I was able to tell him what I wanted to do as an engineer, and I'm going to partner with the Cleveland Clinic to build an MS research center here in Jackson, New Jersey. Jim's right. When I purchased the property, it is 300 acres right next to Six Flags. You've probably seen the signs go up. It says the adventure is coming and MS is leaving. That's the goal. Remove MS from this earth. It certainly has tortured 400,000 people in the United States, 2.9 million people around the world. If anybody in this room has dealt with MS, you know that it affects the whole family, not just the person. When I went to JCP&L, I said I wanted to build this project. They said, where are you going to get the power from? I told them we bring people to the moon and bring them home. You think I'm going to worry about what you can't do? So I went to Jim and I said, Jim, we got to figure out another way. I happened to be an engineer. I knew there was a way. Jim's right. He put the team together and we have a strong team and we found a way to get power to that location. But the rules that I've had to deal with as a developer are incredible. Telling me that I'm supposed to be off the grid by a certain time, telling me I'm supposed to build a $30 million substation. So I put up the money for $30 million and then find out I'm supposed to be off the grid. Well, who's giving me the money back? I'd like to put the money into medical research. I don't want to put it into JCP&L's power lines. The rules that this state has for doing development are incredible. If you follow the rules, you're in a jigsaw puzzle. You're going to hit walls that you can't even imagine. So the first thing we need to do is to change the rules. Yes, I am building a project to save 2.9 million people, but I want to do it while I'm alive, not when I'm dead. They have to change the rules. The rules are out of control. If you follow the rules, you can't do what we're doing. The goal is to kill MS, yes. But we have to build this microgrid and we have to change the system to be able to do it. So if you're in the audience and you can find a way to sit with Jim and Adam and listen to what the problems are, they're pretty simple. Just have to get those things, the blocks out of our way as a developer. MS is a very, very serious disease. I am committed to killing it. I'm asking you all to help me do it. And I'd be very proud to do it under my wife's name. I'd certainly be very proud to do it here in the state of New Jersey. And Adventure Crossing is the beginning to the end of MS. Thank you.
make one more comment that hasn't been noted. All the profits from this project, from Adventure Crossing, is what's paying for that research center. Vito's not taking out the profits. He's putting all of his profits and donating back to build that research center. And by the way, he donated the research center that's named after his wife at Center State as well. So this is a very serious man with a very serious goal. And anything we can do to support that goal is in all of our best interests as a society. Thank you.
Thank you all, Jim. Thank you, panel. We're going to take a quick 10-minute break, go grab some cookies, grab a coffee, And we're gonna start back. We have a really good finish to this panel or to this conference, so no one can leave. Get a cookie, come on back.